All right, so we're going to find the electric potential. Remember that electric potential, right, is KQ over R. Remember that gravitational potential, there's an asymmetry here, right? Because all gravitational potentials are negative, right? And so gravitational potentials, if this is one of the ones that has masses, remember that they're all negative, right? So where is it? Is negative GM over R. Okay, so just be careful. This one's electrical, so we're just going to use electrical potential is KQ over R, which of course means that positive charges make positive potentials, negative make negative. Okay, and what we do here is that the potential at P and the potential at Q, that they just simply add up the potential due to each charge. And it's not a vector, it's just the scalar sum. Okay, so the potential at P will be KQA over R plus KQB over R. We're just simply going to add those up. Okay, and the potential at Q will be exactly the same thing. Okay, R's will be different and whatever, but that's the only difference. Okay, so here we go. Let's find the potential at P. All right, so that is, the potential at P is 8.99 E9. And then let's see, A is negative, right? So it's negative 3.1 E minus 6, right? And then this is, at P, we are how far from that guy? I guess we are just simply 1, 2, 3 from that guy, right? So this is just divided by 3. Okay, and then plus 8.99 E9 times, let's see, B is 2.6, E minus 6. And then let's see, we are 1, 2, 3, and 1, 2, 3, 4. That's 5. So 3 squared plus 4 squared, the square root of that. And in this case, since R is not squared, the square root stays. Right, so this guy is 1, 2, 3, and 1, 2, 3, 4. 1, 2, 3, yeah. Okay. So let's figure out the voltage at P. 8.99. In this case, by the way, I do not ignore the minus in front of that because this is going to cause a negative potential. This is pushing the sheet of rubber down, that's pushing it up. And P is just going to be the sum of those changes in potential. So 8.99 E9 times negative 3.1 E minus 6 divided by 3, okay, plus 8.99 E9 times 2.6 E minus 6 divided by the square root of 3 squared plus 4 squared, which would just be 5. All right, so here we go. Are we ready for this? This potential is negative 4614.9. Negative 4614.9 volts, and that's the voltage at P. All right, did we get that right? Yeah. This is so good to know. Okay. I should put like the answers on the test. Okay, so then the voltage at Q is going to be 8.99 E9 times negative 3.1 E minus 6. And then Q, how far is Q from A? It's 1, 2, and 1, 2, 3. So square root of 2 squared plus 3 squared. Is that right? Let's just double check. 1, 2, 3, and 1, 2. Okay, plus 8.99 E9. Okay, and then this is 2.6 E minus 6. That's a minus, not a plus. All right, here we go. Then it's divided by the square root of, let's see, Q to B to 2.6 is that just 1 and 2? So it's 1 squared plus 2 squared. Okay. Okay, here we go. So 8.99.
Come on, girlfriend.
Let's go.
Are you recording?
Indeed, I am recording, honey. Delete, and then I'm going to go second insert, square root, left parenthesis, and then I'm going to go 2 squared plus 3 squared. All right, and then let's go in here. Okay, so let's see, this guy is 1 squared plus 2 squared. Okay, so did I do that right? 2 squared and 3 squared. There we go. Okay, let's see. So this is 2723.7. That's a positive number. Okay, yeah, so VQ is 2723.7 volts, and that's positive. Let's just look at the picture here. So let's see Q. Yeah, so Q is relatively close to this positive charge, so it's going to be pushed up in general, right? P apparently was fairly close to this negative charge, and so it's the place where the sheet of rubber is pushed down. Okay, so just remember for this thing, you're going to use KQ over R, right? For if it's electrical, or negative GM over R. Okay, if it's gravitational. Remember the minus sign if it's gravitational. Okay. Remember that the distance, that's just R in the denominator, okay? That's because we took an integral and the R squared went away, right? Okay, and so if you have to use the distance formula, you have to use the square root in the denominator. Notice that you don't ignore the minus signs, okay? Okay, they're the only thing you have to pay attention to, positives and negatives. There we go. All right. Excitement.